So for those of you who are unfamiliar with what an aquatic toxicologist may do, I am just going to quickly give a bit of context to what I do in a broader sense. So for those of you who heard the word toxicologist and, oh, I'm not advancing, there we go, and saw something like this, I'm just going to disappoint you early on. I do not magically run instruments that can match a criminal's DNA to APHIS in under a minute. That's forensic toxicology, and honestly, they can't really do that either. But what I do is, I basically work to answer one of 4 questions. I'm having trouble with my mouse, sorry. One of 4 questions. And so ecotoxicologists, which is a much broader term to describe, and it incorporates the field of aquatic toxicology. So ecotoxicologists in general study a really wide range of things. It's a very interdisciplinary field that covers a lot of different topics. But ultimately what all of us are trying to do is address one of 3 different questions. The first question is, how is exposure to living things, or how is exposure to chemicals going to harm living things? The second is, how much exposure can these organisms actually take before their health is going to start being impacted? And the third one is, how severe are the effects going to be? So these first 2 have something in common, and that's that they're generally, when people who are trying to answer these questions are typically doing that in the lab or in the field. They're doing original research studies. And my lab does quite a bit of this work, in addition to the work that I do in risk assessment, which is essentially this third question. So risk assessment sort of deals with this third question that I've highlighted here. And it tries to answer the question, how severe are the effects of some type of contamination going to be? And so at this point, really what we mean when we say how severe are the effects is how badly have we screwed up this ecosystem? So here are some very, very serious examples of some ecosystem impacts where we would expect that the health of these organisms that are in these ecosystems is going to be really adversely affected. So I'm sure the top left one needs no introduction here in Texas or any of the Gulf states for that matter. That is the result of the Deepwater Horizon oil spill. This whale on the top right has died as a result of oiling from the Exxon Valdez oil spill in Prince William Sound, Alaska. This Crayola orange colored river is an example of what can happen when an acid mine tailings pit, the dam falters, and then all of the acid mine drainage with heavy metals pours into a river. In this case, this is the Colorado River. And then on the bottom right, we see that a brilliant example of intentional discharge of some type of contamination directly into the ocean, which looks to be actually next to a beach resort. So that's a little confusing, as well as being very concerning. So we look at these pictures and we think, oh, there's obviously going to be effects on the health of these animals. But what's important to remember when we're talking about contamination is that the health of the environment and the health of humans is inextricably linked. So there's this concept of One Health, which is sort of an emerging idea in toxicology that suggests that since they're so linked, we should really study the interface where these sorts of contamination events can affect the health of both humans and of the environment, and then how those 2 things connect to one another as well. And there's really probably not a better example of One Health than human exposure to contamination through fish consumption. And so that's really going to be the focus of my talk tonight. And so we're going to get right into that. So subsistence fishing in general is a global practice. So here are examples of people that are doing different types of subsistence fishing practices. It's an enduring and global practice, and it has a common goal, and that's typically to feed your family. And so the methods can, of course, dramatically vary, as you see in these pictures. And there's a number of reasons for that. The first is that all of these people live in extraordinarily different ecosystems, and they're working with different habitats. They're trying to catch different fish species. They may not have traditionally had access to materials that would be needed to make other types of fishing tools. And so these and they may not also have alternatives beyond seafood or food from the river. So in a lot of cases, subsistence cultures will sort of also hunt, and they'll also gather in addition to fishing. And for some, land game isn't really available at the level that they need it to be sustainable. So some subsistence cultures can afford to be a bit more picky about the types of fish that they're going to catch, perhaps like the spear fishermen. Whereas in other instances, you're just trying to trap as much food as you possibly can to meet your nutritional requirements. And so I mentioned that nutrition is really the ultimate goal of subsistence fishing practices. But it's not really the only goal. So depending on how, dire the need to catch food is, people may or may not actually actively think about the other benefits of subsistence. But because, as I mentioned previously, it is a very distinct part of a culture that has evolved to be sort of part of the cultural and traditional knowledge that a person grows up with. They often will, and it's also deeply personal because it's based on their connection to the land and what they know about their environment, and it's often passed down through generations. So the result of that is that while nutrition is an important component of subsistence fishing, it's not the only one. So subsistence fishing represents an opportunity for many to connect with their community, with their ancestors. It represents an opportunity to pass on traditional knowledge and values to the next generation. And in some cases, it actually is very important in determining and maintaining social standing, and also displaying your leadership skills within your community or tribe. This is especially true in sharing cultures, where the entire community will pool resources, and the more affluent families may have the better boats, or they have the better tools, and so they are charged with sort of redistribution and contributing more than their share for the good of the community. And depending on how isolated the community is, subsistence fishing may actually be a really large part of their non-monetary economy. So, for example, if you have some money, but you live in the middle of an absolutely remote rural wilderness, there's nowhere to spend the money, so the money really has no value. Whereas if you have fish and your community members are faced with food shortages or in need of food, really your economy is going to be based on the sort of bartering power that you have to trade for other resources that your family may need, which can be in the form of fish, actually. So if I had to sort of think of one umbrella term that could incorporate all of these different components, it would really be quality of life. And so that's a pretty, loaded fish. But here we have just sort of an example of how subsistence fishing really is contributing to the overall cultural identity and quality of life for many, many of these communities. Now, there's always more to the story. I just had a really glowing review of subsistence for many of you. And so the question is, are there any disadvantages at all? Some people don't like the way that fish tastes, so that's a major drawback for some people. I'm just kidding, that's not actually a talking point. It's a nerdy joke that I am attempting to pass off as real humor. But there are some real drawbacks. And so we have here an example of some of the major drawbacks, which primarily relate to contaminant exposure. So when we talk about fish contamination, there are really 4 major contaminants that we're concerned with. And these are polychlorinated biphenyls, which we call PCBs, organochlorine pesticides, which are not really used in the US anymore, but they also are really stable and don't break down. And so they're present as legacy contamination. And then dioxins and furans. And the 4th one is mercury. And so it's not just mercury in general. More specifically, it's methylmercury, which is the form that accumulates in fish to potentially high levels, which we abbreviate with, as you can see in parentheses there, MEHG. So when I mention mercury going forward throughout the remainder of the presentation, what I'm really always referring to is this specific form, methylmercury. And so why am I only talking about methylmercury when there are 4 different contaminants that I said are major issues? Well, there's some pretty good reasons for that, which of course I will discuss right now. These first 3 here, the PCBs, organochlorine pesticides, and dioxins, are lipophilic. And what that means is they're fat-loving compounds. And so when they are present in the environment and start to accumulate in animals, they mainly accumulate in the organism's fat. And so I think for many of us, the fat of the fish is not generally the most prized part of the fish that we catch. And so for that reason, we may not, just because of our food preferences, since we're not eating the entire fish like an animal might, we're going to be like less inclined to be exposed to these at high levels at a general level. So of course, depending on the water body, that may not be true, but generally speaking, we avoid the parts of the fish where these things accumulate. Whereas methylmercury is not fat loving. It actually does accumulate in the muscle of organisms. And that is, of course, the fillet, which is the part that people generally prefer as a food item. And so mercury also accumulates in higher trophic level organisms. So organisms that are higher up in the food chain will eat smaller organisms, each of which has accumulated their own concentration or body burden of mercury. And so for every fish that you, as a large fish, for every small fish you eat, you pick up all of their methylmercury as well. And so you can imagine that in really long-lived, large predatory fish, the concentrations of mercury can be quite high in the muscle. The other thing is that besides the fat-loving versus muscle-loving components, there are a number of sources of these first 3, but generally what we find is that PCBs, pesticides, or dioxins are generally from local contamination. So we can typically point to a type of industry that's discharging into the aquatic environment, or we can point to a military installation that used a lot of organochlorine pesticides and there was runoff. So we sort of know where the contamination came from in the cases of these things, which, you know, if you know what you're looking for and you know where to find it, then you can do a better job of warning the public that, hey, these fish are high in PCBs, you probably shouldn't eat them. But that's not really the case for mercury because of a few reasons. So we consider mercury to be a global contaminant. And what do I mean by that? So what I mean is that sources of mercury that cause air pollution, like coal burning, any type of fossil fuel burning, but especially coal burning power plants, they will release mercury into the atmosphere as air pollution. And what's unique about mercury is that I mentioned previously, there's that special form methylmercury that's in fish, but it doesn't start off that way. It starts off as the silvery, shiny substance that we think of in thermometers, which is really, really volatile. And so it enters the gaseous phase as soon as it gets heated up. and it just circles around the globe in the atmosphere. And it can actually stay there for up to 2 years until it becomes oxidized by some kind of atmospheric constituent, at which point it can stick to little particulates and fall out of the sky, or it can come down in rain. And so we call that deposition. So what that really means is that all of the mercury that is present in this tuna could have come from anywhere in the world, essentially. So it could have, come from a local source, a coal burning power plant, maybe in Texas, or it could have come from a gold mine in South America, or it could come from a coal burning power plant in India. So for this reason, because of this global transport mechanism, we find that all fish to some degree has mercury in it. So it may be low enough that we're not really able to detect it with instruments that we currently have, but there's going to be some mercury in every fish somewhere. So for all the reasons that I just mentioned, mercury contamination is overwhelmingly the most common reason that fish consumption advisories get issued in the United States. I would wager a guess that it's also probably the most common one elsewhere, but I'm less familiar with their regulatory frameworks. So, in fact, mercury contamination is so abundantly the major issue that over 3/4 of fish consumption advisories in the United States are due to mercury. There's some other reasons that mercury is of particular concern in fish, and that's because of the way that it can be absorbed into your body and the effects that can result from that. So I mentioned previously that the methylmercury form is the kind found in fish. And it's also the kind that can be absorbed into our bodies very easily. So that metallic form I mentioned previously, or inorganic mercury that's just falling out of the sky stuck to a particulate, those types of things are not easily absorbed by our bodies. And so they're going to be much less toxic because they're difficult to get into our bloodstream. And that's unfortunately not the case for methylmercury. Methylmercury, about 95% of the methylmercury that's in your food is absorbed into your body and enters your bloodstream. It also can be and is actively transported from mother to fetus, which means that during the fetus's development, if the mother is being exposed to dietary methylmercury, so also is the developing fetus, which is a concern in some cases because methylmercury is extremely neurotoxic, especially to very, very young life stages, so babies and children and fetuses. And unfortunately, any of the toxic impacts that are experienced by these very young life stage children and babies are expected to be permanent. So the impacts from mercury toxicity are a lifelong burden. So because of the potentially serious health threats that mercury presents, the federal government, the EPA and the FDA jointly got together. They got their best and brightest ecological risk assessors and human health risk assessors together. They analyzed tons of data from all the fish monitoring programs at the state level that had data available for them. They collected their own data, they modeled exposure, they did surveys of how much fish the average American is eating, and they came up with some recommendations for people. And this is nationwide recommendations for people who do eat fish. And so the recommendations that they came up with say that anyone that's over the age of 10 essentially should eat a minimum of 8 ounces of fish and a maximum of 12 ounces of fish in a week. And this minimum is really important to point out because I said previously that mercury is a really potent neurotoxin. It can be transferred from mother to child, but the thing is that fish is such a wonderful and nutritious source of a lot of different vitamins, and it's a very lean protein. And it also has a lot of different components that are essential to neurodevelopment for babies, like selenium. And so you have to carefully balance the benefits that come, the health benefits that come from eating fish for a developing fetus. And you have to weigh it against the potential risks of mercury being present at high concentrations. So to help sort of tease out and reduce the risk for the average person, the FDA and EPA didn't just give a numerical amount of fish to eat. They also classified the fish by the best choices, which are considered low in mercury, good choices where you really shouldn't eat 12 ounces a week. You should only eat 4 ounces a week. And then they have a different category of fish to avoid entirely because the mercury levels are very high. And so this advice has been really helpful to a lot of Americans. So if you need some context for how much 8 to 12 ounces is, a deck of cards is about 4 ounces. So when you have, you put this overall weekly advice into context, it would be equivalent to eating about 3 decks of cards worth of fish. So let's get some more context, because I think for most of us who, I would say most of us who eat fish but aren't like huge fish enthusiasts, 12 ounces is probably about right per week. That seems pretty reasonable for most of us. So Americans have, and just people in general, have a lot of divergent opinions about fish. Some people are just repulsed by the smell. They can't get over the texture. They just think fish is absolutely the worst. Some people tolerate it. They don't love it, but it's fine occasionally. And so I would feel pretty confident generalizing that those 2 groups of Americans feel just fine about eating 8 to 12 ounces maximum of fish per week. So there's a 3rd and 4th category here of my frequent fish consumers. So those who find fish to be wonderfully delicious and really enjoy eating it regularly. And so those people are on average eating about 12 ounces per week, just I guess not by chance, but it just so happens that they eat around the amount that the advice, the FDA's advice says is the maximum. So that 3rd group in general probably agrees that this is reasonable advice. But we've got this 4th group here that NHANES surveys classify as heavy fish consumers. And so those people are the Americans that end up eating about 21 ounces of fish per week. So that's definitely more than 12. And they're, less likely to feel the advice is super reasonable, but it's not many, many times over the fish consumption advice. And I'm sure there's some variation in there. So what's really important about this picture, though, is that we're missing a really a small group, but a very, very important group of people who might be experiencing the greatest exposure. And so those are the subsistence fishermen and women. And so to look at this issue and the risk that these people might face and how they might feel about the fish consumption advice, we turn our gaze to the great state of Alaska. And that's because they have an incredibly high prevalence of subsistence fishing relative to other states. In Alaska, most people rely on subsistence to some extent, even if they live in Anchorage and are able to go to the grocery store. Anchorage is about the size of Corpus Christi or Plano. And so there's lots of grocery stores to go to, and people still do subsistence fishing as a normal practice. So despite the fact that Alaska gets left off of every single map on the news that is about any kind of statistic ever, seriously, I pulled some clip art and it didn't even have Alaska on it. We are still Americans, though. So I'm going to go back to my previous graphic for just a moment, and I'm going to include Alaska here. So Alaskans do not, I would say on average, feel that the 12 ounces is enough fish for them. The statewide average for fish consumption for Alaskans is actually 37 ounces of fish in a week, which is just over 3 times the federally recommended maximum. Nearly all of that fish is salmon. Overwhelmingly, salmon is the primary fish that Alaskans consume, followed at a distant second by halibut. And so in some cases, because there are regional differences in the amount of fish that different people eat, in some cases, the average in some regions of Alaska is actually up to 47 ounces per week, which is much, much more than 12. So if you're thinking, oh my God, every single person in Alaska almost certainly has mercury poisoning. She said it's in all fish. They're eating just massive quantities of fish all the time. That would make sense, but biomonitoring data actually tells us a very different story. And so I'm going to present that biomonitoring data, the results of that later. But first, I want to talk about the reasons that people in Alaska and other subsistence communities are just eating so much fish when it's understood that fish can be contaminated with mercury and there is a potential health risk. And so this map is pretty much the reason that people are so reliant on fish in Alaska. This is the entire road system for the state of Alaska. So there is a remarkable lack of transport infrastructure in the state. And it's important to point out that Alaska is 18% of the land mass of the entire United States. It is absolutely massive. I know that Texans pride themselves on everything's bigger in Texas, but Alaska is more than twice the size of Texas, in fact. And it also has a population that's about 3% of what Texas population is. So when I say that, you know, these are rural communities, they're incredibly remote, tiny, tiny villages that may be composed of only a few families. And so I probably don't need to point out the obvious here. There's not much of an alternative to subsistence fishing in many of these places. You can subsistence hunt, certainly, but you know, there's other, I guess it's more difficult in some cases, and it's much more dangerous, I would argue, in a lot of ways. And it also does also carry with it some potential for contaminant exposure as well. But back to fish, any of the supplies that end up in these communities that I'm discussing, they are not easily gotten. So they are flown in on small bush planes, often under very dangerous conditions, and they carry only what they can in these small planes, which, you know, are weight restricted. So the result is that, and I'll also point out that no matter how green your thumb is, no one is growing any crops. First of all, I'm not sure how you would routinely get seeds and fertilizer, but even if you did, judging by its latitude, as you can see, there's really very little chance for formal agriculture to be sort of a sustainable way to feed your family throughout much of the year. So food's not just hard to get. The price of food in rural Alaska reflects the effort and expense that bringing cargo into some of these communities requires. So these, most communities do not have store, but some of the communities off of the road system do have, if they're coastal and there's a navigable channel, they can receive cargo from boats. And so for communities that are lucky enough to have, and large enough to have a general store, it will just be one store, they'll sell food at just astronomical prices. So if you look at some of these pictures, the watermelon is truly shocking. It's almost $37 for not even a whole watermelon. And I have eaten watermelon in Anchorage, and I will tell you, it is mealy and disgusting. So, We also have our nearly $10 milk and our almost $14 juice. And so when you look at these prices, it's not just hard to get, it's hard to afford to eat healthy. Not that simply lemonade raspberry is terribly healthy, but it is, like a fresher food that's not something out of a can or out of a box that has a long shelf life. So, and those are the types of foods that people have to turn to in these communities if they're not subsistence fishing in many cases. And the reason for that is that by the time food arrives in Anchorage, the main distribution point, it's already pretty old. And so then you have to take it from Anchorage and fly it out to these remote communities. It takes time for people to go to the store and buy these things. And by the time they get it to their fridge, produce is probably already turning. And so I'm not sure about you guys, but I certainly cannot afford to waste $37 on a gross watermelon that expires the next day. And so people end up eating nutritionally deficient processed foods that can remain on a shelf for forever. And the sad reality is that Alaskans are increasingly choosing to do that. Subsistence rates have been falling in the recent decades, quite a bit, in fact. In 1980, a subsistence harvest accounted for about 400 pounds of a person's food per year. And now it's down to about 275 pounds, and that was in 2014. So I'm sure there have been further declines. And the reasons that these communities give for these declines when they're surveyed is almost always two things. Why are you choosing to eat these processed foods instead of subsistence fishing? Well, I don't know where the fish are anymore. The types of fish that used to be here aren't here anymore. There's salmon here. If you're on the Arctic, they didn't used to be here. They couldn't make it up this far. The tides are changing, the patterns are changing, the water temperature is changing. So it's not very reliable in some cases for these communities that have to catch large amounts of fish in order to make ends meet for the rest of the year. And so climate change is definitely playing a role there, but overwhelmingly, these communities say that they're worried about mercury contamination, which is really very interesting. They don't really know, in general, when you'll sort of inquire further about it, they're not sure how they became concerned about mercury in their fish specifically. But there is this very prevalent and increasing idea that mercury and other types of contaminants have made their food unsafe to eat. And so all of the things I've discussed so far, the lack of transport infrastructure, the inability to have sort of formal agriculture, and the food prices have led to extraordinarily high rates of food insecurity across the state. In some of the harder hit areas, which are, and all of the villages that are listed in this graphic are actually they're considered sizable. But in some cases, some of the hardest hit communities are approaching 46% of homes that are food insecure, meaning that they're skipping at least one meal a day, or they have no idea how they're going to get enough food to last until it's warm again. So when you think about all of these challenges facing these communities, it begs the question, what's the greater risk? Is mercury exposure from subsistence fishing the greater risk? Or is potentially having extremely bad nutrition and having maybe not enough food to make it through the winter? So, worst case scenario, starvation. What really is the greater risk here? As a public health official, what recommendations do you make to these communities who are looking to you for guidance and want to know how to best protect their children? So the first step in answering this question as a risk assessor is to always model the actual exposure that the person or the community that you're analyzing risk for. And I know that sounds obvious, like, well, of course I would want to use data that applies to the people that I'm going to analyze the risk for. But it's really not that simple. Because the FDA and EPA risk assessors, when they came up with their fish consumption advice, they were tasked with developing just sort of a blanket standard that would protect everyone in the nation. And so looking at this graphic, we see that, we have some states that have one fish consumption advisory, and we have Minnesota with over 1,000 active fish consumption advisories. And you'll also notice that Wyoming there is claiming to have 0. And that's actually because they did not have a fish monitoring program and were not reporting data to the EPA at the time that the map was made. They now have fish consumption advisories. But anyway, so looking at this map, you can see the challenges and the dilemmas facing the risk assessors. So how do you protect the health of all Americans when you're faced with unique circumstances for some of these communities who really, for various reasons, do need to eat fish in order to meet their nutritional requirements? So we're talking about these remote communities in Alaska. So this begs the question, since this map does not feature Alaska, what is the situation on a scale from Nevada to Minnesota? Where does Alaska land? And so what I did was I went to the EPA fish consumption advisory database and just pulled some graphics of the fish consumption advisories that are in states with really high proportions of land that's considered coastal. And so if you see the state, the colors mean what you would think they would mean, right? Red is never good. So here we have Hawaii, we have New Jersey, and we have Florida. If the whole state's shaded in, that means there's a statewide consumption advisory, and the severity is dictated by the color. And then you also see these red squiggles on different rivers, and those are sort of sites of local pollution that have warranted localized fish consumption advisories, but it doesn't apply to the whole state. So as you can see, Florida is not in a good state. Hawaii actually has a statewide fish consumption advisory for quite a few fish due to mercury. Texas, I know everyone's going to ask. I know we don't have a ton of coastline, but I would want to know. So here's Texas. You'll notice the state is shaded in. So that does mean that there is a statewide fish consumption advisory, but it's green. Green is good. The level of severity is not considered high. And I'll go ahead and spill the beans on this one. All of the Gulf states that border the Gulf of Mexico are going to end up being green because the entire Gulf of Mexico has fish consumption advisories for certain types of fish. And so here's Alaska, also green. There is a statewide fish consumption advisory that's been issued. And that really surprised me. I hadn't heard of such a thing. And so I did a little more digging, and the advisory, according to the EPA, that they're shading it green for is that Alaska issued a statewide guideline to inform the public that all of their fish are safe to eat in unrestricted quantities. So that is their statewide fish consumption advisory, which is actually pretty hilarious. So I mentioned you want to use sort of the parameters that best describe the population that you are investigating the risk for. And I mentioned that these communities have much higher rates of fish consumption than the average person in the United States. And so you also want to use concentrations in your exposure estimates that are going to represent the fish that these people are actually eating. So that takes a lot of data. And fortunately, the state of Alaska Department of Fish and Game has a whole division that is devoted to subsistence surveys and data collection. We know that people are overwhelmingly eating salmon. We also know that the rates vary by region, and we have consumption rates that apply to each of the regions, the 6 regions that Alaska is broken into. And so that's wonderful news to be able to sort of provide sort of a more refined idea of risk to different populations. So there are 5 types of Pacific salmon that are native to Alaska. We also know what percentage of the overall fish consumption for each of the community or each of the regions is composed from each of these 5 species of salmon. So really, it's a pretty remarkable effort that the state of Alaska has undertaken to provide the parameters that are needed by risk assessors to appropriately gauge the amount of risk that these people are experiencing. The other factor, besides the concentrations in the fish and the exposure that, the rates of fish consumption in general that can vary, is that, of course, you need to consider variations in body size and things like that when you're doing these calculations. So after we model these types of exposures for these populations, and we get our final answer, as it were, in math at the end, we end up with something called a hazard quotient. And a hazard quotient, which is abbreviated HQ, is considered to be not a health risk if it's anything less than 1, and if it's above 1, then we say to ourselves, okay, well, we need further toxicological evaluation to determine whether this is really a risk or not, but it warrants checking out. And so the FDA EPA fish consumption advice is based on keeping that HQ below 1 for the average person in the United States. And so when they did that, they used all of that state monitoring data submitted for fish all in every single state across the US, which, as we saw previously, the contamination levels can vary considerably between the states. So how do Alaska's fish compare? And so this is just a comparison of the 5 types of Pacific salmon, which is chum, coho, king, pink, and sockeye. And then there's also Atlantic salmon. Most Atlantic salmon is farmed, but there are some wild populations. And so these actually represent wild Atlantic populations, which is difficult data to find. But as you can see, we have only values for any salmon, regardless of where they come from or what species they are. All of the average concentrations are below the EPA risk-based consumption limit for mercury in fish. And they're well below the FDA's maximum allowable level, which allows you to have 1 part per million of mercury in fish and still sell it in stores, which is much too high, in my opinion. But going back to this idea of, Alaska's fish relative to other types of fish, we also have the Pacific salmon broken out by state. And so Alaska is the black bars there. And then we have British Columbia, which of course is not a state, it's in Canada. And then we've got Washington, California, Oregon, and Vermont and New Hampshire represent the Atlantic populations. And in each instance, Alaska is lower or equivalent to concentrations that were found in the other states that also have wild Pacific salmon, with the exception of chum, which there just wasn't much data for. Alaskans are quite snobby about their salmon, and they consider them dog salmon. And so they're not really that frequently consumed by humans anyway. And they're still remarkably clean. So all of the hazard quotients, when we look at, even with the extraordinarily high concentrations of of fish, even with the extraordinarily high rates of fish consumption that are in Alaska, multiple times the maximum advisable amount that a person should eat, we still find that all the hazard quotients are below 1. So when we look at it just from a mathematical perspective, doing exposure modeling and evaluating it against the effect concentrations we know to be of concern for developing fetuses, which is really the most sensitive population by far to mercury exposure, we find that it doesn't seem that there's much of a risk. But of course, if you're a parent and you are concerned about the amount of mercury that your child with a developing nervous system is being exposed to, that may not be enough for you. You might want to know, well, are you sure? What else do you have to support this? It's math, it's modeling. And so that's a completely understandable sentiment that can also be addressed. And so one of the ways that public health officials address this is by doing hair mercury monitoring. And so people actually secrete mercury in their hair, which is it correlates with their dietary intake of mercury. And almost all of the mercury present in hair is also in the methylmercury form. So it's actually a really inexpensive and non-invasive way that people in the state of Alaska can get an idea of how much mercury they're being exposed to. And so the state has been doing this since about 2007 and has over 1,000 hair samples just from women of childbearing age in the state of Alaska. And what we find is that despite having very equivalent consumption rates, fish consumption rates with other populations that rely almost exclusively on subsistence fishing as a way to meet their nutritional requirements, the women in Alaska have remarkably low hair mercury concentrations. There's actually a no observable adverse effect level. That's what no AEL means. And it's that red dashed line. And so that line has been indicated at the hair mercury concentration at which effects on children are expected to start occurring as a result of exposure to methylmercury. And so looking at this chart, you can see here that Alaska, which is the far left white bar, is very, very far below the adverse effect level that you would expect to see effects from mercury toxicity at. So there are quite a few explanations for why that may be, and I have a lot more data that I'd be more than happy to share with people at another time, but for the sake of time, I will not get too deeply into that today, and instead I'll just give some overarching conclusions here. And the first is that based on, and the most important, is that based on the public health trends that we see when people aren't using subsistence fishing lifestyles, when they switch to those nutritionally deficient boxed canned foods, we tend to see increasing rates of diseases of poor nutrition like diabetes, cardiovascular disease, and we also see a lot of increasing mental health crises, and suicide rates have increased a lot as well. So we have these concerning public health trends as these communities shift away from their subsistence lifestyle. And then we have a wealth of data that shows that there's very, very low concentrations of mercury in the fish that these people are actually eating. And then we confirm that further by saying, wow, these women and children have remarkably low concentrations of mercury in their hair, especially compared to other people who eat the same amount of fish. And so going back to that idea of which is really the greater risk, is mercury exposure from subsistence the risk, or is not eating fish and not following your traditional subsistence lifestyle the greater risk? And that answer is going to vary according to all of the parameters that we discussed today and quite a few others. And so you really can't come up with national blanket guidance or global guidance for many of these populations that have very specific cultural practices, or they're very isolated, or have other unique circumstances, and a startling lack of alternatives to eat if they're not eating the fish. And so based on all of these things, really the primary thing that I would offer as a conclusion is that the benefits in this case for Alaskans, the benefits of their traditional diets appear pretty confidently to outweigh the risks that they may experience from any mercury exposure through their fish. And I also think that it really highlights the importance of using regional data in high stakes situations such as these, where people don't have alternatives, and the stakes are pretty high in terms of what the consequences can be if you're wrong about your risk predictions, or you make recommendations that they're not one size fits all in some circumstances. So from a risk assessment perspective, I just think it really underscores the importance of considering holistically who is the community I'm evaluating, and what are the relative risks if I advise against a certain practice. And so with that, I just want to acknowledge all of the amazing contributors that contributed data to the study. It was a lot of data collected over a number of years, and a lot of people worked on sort of bringing this all together. And so I would like to, of course, acknowledge them, and the state of Alaska for funding the work as well. And with that, I shall take any questions.
Well, Dr. Nielsen, thank you so much. That was really interesting. So I have a question. And if I was reading the charts right, there were some subsistence fishing populations that had higher levels of mercury, is that correct, than the people in Alaska? So,
right.
So how do you account for that? Are there fish that they're eating much higher, and in mercury, and is that relative to proximity to lots of coal burning power plants? Or is it?
Well, that's a really complex question to answer. It could be because of local pollution, certainly. It can be because of the trophic position of the fish they're eating. So maybe they prefer to eat very large predatory fish. So tilefish, orange roughy, sharks, things like that, that a lot of cultures don't eat. Some populations of subsistence people really do prefer to eat those things. And so the type of fish you're eating is huge. The location is really important, both in terms of how much contamination, local contamination may be contributing, but also because their selenium I mentioned earlier actually is thought to mitigate some of the adverse health effects of mercury in fish, as long as it's present in equimolar or greater ratios to the mercury in the fish. So there's a lot of other interactions between, at the molecular level that can also potentially be reducing people's mercury exposure. And then the third thing is that a lot of populations who are subsistence, heavily subsistence fishermen also may consume marine mammals. And so a lot of the contamination can also come from other mammalian sources as well. And so it really is so important to consider what the people are actually eating and what the concentrations in those dietary items are. Because as we've seen, just using, you eat this much fish, you're probably at risk or you're not at risk, isn't really going to work in a lot of these communities.
Okay, and one of our participants, maybe touching slightly upon that, said, I vaguely recall the enzymes in some stain removing laundry detergent from the early 70s reacting with mercury compounds in the sea floor / riverbed, drawing them into the water, making them bioavailable. Do I have that right? And what were those enzymes?
I am actually not familiar with what that was. I guess I'm feeling a little bit uninformed on that issue, so I'll have to look that up. But you may very well have it right. Selenium would not be an explanation for that, because they bind to one another irreversibly, which means though you may have fish that have mercury in it, and though you may eat that fish, it's not free to do any harm in your body, because it much prefers to stay bound to the selenium than anything else that's in your body. I'll have to look into that other question, and I do hope that you'll send me an email so I can follow up with you after I look into it.
Okay, and then someone else asked, could it be that Alaskans' microbiomes have adjusted to remove methylmercury?
So that is a remarkably interesting question. The microbiome, of course, and I guess maybe I don't know everyone's foundation with the gut brain interaction here. So your gut is, of course, populated by an unbelievable number of microbes. And they communicate actually bidirectionally with your central nervous system. So in some respects, the bacteria in your gut, and they're actually giving your, they're communicating with your brain to change certain behaviors and modify different processes in your body. So it's a new area of work where we're sort of, as toxicologists, we're looking at how contaminants can alter the microbiome of of people or whatever your test subject is, and what the resulting effects on your nervous system might be. And so mercury can, as I mentioned, methylmercury is the specific form that causes, these toxic effects at fairly low concentrations in humans. And bacteria in the gut microbiome can also potentially methylate or demethylate mercury. And so it's still kind of unclear to what extent you have the demethylation and methylation occurring, and whether, that's playing. There is data to suggest, and I have actually done studies myself to suggest that mercury affecting the composition of your microbiome is going to potentially lead to some of those neurotoxic behavioral changes. And so it's possible, but I couldn't say definitively one way or the other. There's just not enough data to say that on the specific microbiome composition of Alaskans. But I would say that based on the fact that we're working in the part per million concentration range, it's likely to be more than just evolution of the gut microbiome. There's certainly going to be just, very simple explanations in those cases where, oh, well, our fish doesn't have a lot of mercury in it.
Okay, and I did want, so we do have a few more questions coming in, but I did want to point out that it's 8 o'clock. So if you are willing, to stay on, we can field a few more questions.
Oh, sure. Yeah,
okay.
That's me.
And I will remind everybody that our next talk is going to be an added talk on March 23rd at 4 p.m. So look at the Texas Science Festival website for that. So our next question is, how did Alaskans become conscious of their mercury consumption if statistically it's not a severe problem and they're not a risk from it?
Yeah, and that's a wonderful question, and that is well, I have a lot of thoughts on that. First of all, that's part of the risk of issuing a national fish consumption advisory, is that it doesn't apply to everyone equally. Some people may not be able to actually eat 12 ounces of fish safely, depending on where they're catching their fish, or it might be a salmon, but it might be particularly contaminated just based on where its home range is. So I think part of it is that you have, this blanket advice that's been issued. They're aware that they eat much more fish than the rest of the lower 48. These communities, of course, are very isolated, but they're also of great interest, I should say, to scientists. So a lot of scientists come in and out of these communities, and there's a lot of studies being done. And, I think in some cases, sadly, many of the communities actually feel like they're lab rats. And so, there is communication to some degree, but then the scientists typically aren't great with following up or communicating results. It's one of the major complaints that we hear from these communities is, oh, well, that person came and they took all this data from us and they never even told us what they found. And so I think they end up only getting part of the story, which is, it's a real environmental justice issue, to be quite frank. they really are experiencing potentially, because of the amount of fish they eat, they're experiencing potentially the greatest exposure. It turns out that's not the case, because fortunately the fish is low in mercury that they're eating. But when we have a population that relies so heavily on fish as just to make ends meet in terms of their energetic needs, they really need to know almost more than anyone if their food's safe to eat, and they need to know the whole story in terms of what the fish consumption advisories really mean. And, it doesn't necessarily apply to everybody. We need to take a closer look at this. But they're just not getting the attention focused on them, because understandably, when a government has limited resources, they have to sort of target the average person. And it's certainly living out where they live is not an average situation. So I think sometimes they get left behind.
Okay, and I have one more question for you, and I think it's quick, but I may be totally wrong. But
Sure.
Can the body remove mercury and other contaminants over time?
Yeah, so that depends on the contaminant, and the length of time that it takes depends on the contaminant as well. So mercury has a half-life of about 180 days in the body, but again, that's a half-life, and there's additional exposure sources probably during that 180 days. And that's only the time it would take to eliminate half of it. So that's also an estimate, and it depends on where in your body the mercury is actually sequestered. So yes, it can eliminate mercury in a short answer. And I think that's true for most contaminants, but it's certainly not true for all of them. So sometimes we see that concentrations do decrease over time, but it's not because you're metabolizing them and actively removing them. It's simply like passive elimination over time. But in general, yes, you do expect people's contaminant concentrations to go down over time when exposure stops.
Well, thank you so much. You've made it through all our questions, and it was a really interesting topic. And of course, people down here on the coast are especially interested in this topic because we catch and eat a lot of fish down here too. So thank you very, very much.
Yeah. Well, thank you for having me. I really had a great time. Great questions.
Have a good evening.
Thank you.